In this tutorial, I'm going to explain the Central Limit Theorem. I will try my best to explain it clearly, and I'm already laughing myself, so I'll do my best to explain it, and you can make a judgment at the end to see whether I explain it clearly or not. So here we go. Let's just start with a simple example. I always find that it's a good idea to using an example as simple as possible to understand not just this theory but any other theories. Here we're going to using rolling a die as example. To begin with, we can say that we're going to roll the die 10 times and you can calculate the mean 3.6 and you're going to do it again, calculate the mean 3.6. You might be wondering that are all the mean are going to be 3.6? Not necessary. Even though both of them mean are 3.6, but you can see that the number combination are not exactly the same. And we can do it again. So this time the mean is 2.9. And do it again, the mean is 3.6 again. But you can see that the number combination is different from the first two. And do it again, we're going to get the mean 3.8. And we're going to do it another 14 times. And we're going to get 14 rows of data. We're going to get 14 means. Lastly, we're going to do it one more time. We're going to get another one mean. In total, we are doing like 20 different samples. And basically, we're getting like 20 means. After getting these 20 means, and we can create a frequency table. So basic idea is that we can find the start with the smallest number. So the smallest number is 2.2, yes. And the frequency is 1 because we only got 2.2. So we can say that 2.2 is 1. And next, we are going to look at another number, which is 2.7. So 2.7 also, it only has 1. So this is 1 here. And we can do it go one by one, and then we can create a frequency table. A lot of numbers have the frequency of 1. And when we get to the 3.5, we can see that 3.5, the frequency is 3. So you can see that there's a 1 3.5, 2 3.5, and there is another 3.5. So we have 3 3.5 in total. For 3.6, we have 4 3.6. We have 2, 3, we have another one, yes. So we have 4 3.6, and then we can go on, and I think that's it. We have all the number. The largest number is 4.3, I think. And you can sum this frequency up. Basic idea is that this frequency basically is summing up the frequency. The sum is 20. We have 20. And after get the frequency table, we can create called frequency histogram. Basic idea is that we're going to start with a line. So basically, we start with roughly 2.2, and then the largest number is 4.3. And here we are beyond this 4.3, but it doesn't really matter. So basic idea, we kind of like have a line. And then we're going to add a frequency. So for instance, 2.2, the frequency is 1. So we're going to add 1 box there. And 2.3 is empty, yes, because we do not have any number 2.3 observed in the mean. And so we leave empty. And then we go to the 2.7. So we add another box 2.7 here. We can do 2.8, 2.9, 3.0, 3.3. And 3.5 has slightly different from those numbers. It has the frequency of 3. So we're going to the box will be 3 boxes. And then 3.6 is 4 boxes. And then 3.7 is 2 boxes. And then we can do all other numbers as well. So as you can see that, so this is called frequency histogram. And we can actually you can manually or use computer program to draw over the trend line. As you can see that it looks like, of course I just like use just randomly draw one. It's not necessarily very precise, but you get the idea. it looks like a bell shape, like a normal distribution. Yes. So the histogram show distribution. So you can see that the histogram show distribution of the mean of the sample. This 2.2, these are the mean. Yes, these are the mean. Importantly, it looks like a normal distribution. So that comes to the theory, the Central Limit Theorem. The Central Limit Theorem basically states that the distribution of the mean approach a normal distribution. So this is the first piece of information in the theorem. So we already saw that on the last slide, yes, the distribution of the mean approach a normal distribution. Another piece of information is that as the sample size increase, I'm going to explain it in a bit. So what exactly is sample size here? So this is the example we just saw, yes. In this example, the sample size is 10. Because in each sample, we roll 10 times, we got 10 numbers. Of course, the n can be larger, yes. You can be going to like for instance, you can roll like 30, yes. You can roll 30 times and then you can get 30 numbers to calculate the mean. The basic idea is that as the sample size gets larger, in general is better. So ideally, the rule of thumb number is 30. Okay, here I only use 10 because if I have 30 number, the table looks very chunky, yes. So I just stick with 10. But ideally, in generally, the recommendation is 30. Okay, the last piece of information is regardless the share or the original distribution. So what does it mean? Basic idea is that x in the example of rolling the die actually follow normal uniform distribution. Each number has exactly the same probability as the other 5 numbers. It basically is it's pretty flat. Yes, you can see that each you plot it. Basic idea is that each number has the same probability. The mean we calculate 20 means. Yes, the mean actually follow normal distribution. So earlier it looks like this. Yes, we can plot it and it looks like a normal distribution. So this is what it means, that the mean will be follow the normal distribution regardless of the original population distribution. To summarize, Central Limit Theorem suggests that if the sample size is large enough, regardless of the original population distribution, the sample mean will follow the normal distribution. So the example we just used was that the x followed the uniform distribution, but its sample mean follow a normal distribution. And actually not just uniform, it can be other distribution as well. For instance, it can be exponential distribution. And so we can see that, so this is exponential distribution. The lambda is, we use the lambda as 1, and we plot it. And then this is the sample mean distribution. To better understand Central Limit Theorem, I believe it will be beneficial that you have very clear idea regarding the distinction between theoretical distribution, sample distribution, and sampling distribution. Let's just use the example we have been using. So for the theoretical distribution, for instance, the example we have been using, the rolling the die example, as you can see that these 6 numbers have exactly the same probability, and so we plot it, all then have the same height. You will want to have a visual understanding of the theoretical distribution. For sample distribution, is that, for instance, earlier, this is the first sample we just saw earlier, yes, and it has 10 numbers, so this is one sample. So when we talk about sample distribution, we're talking about one sample from the population. And so and then we can plot it actually. So this is the frequency histogram, and so as you can see that the number 1 have frequency of the 2. Yeah, so this is 2, number 2. And similarly, the observation of 3 also have frequency of 2. And the observation, the number 4, have frequency of 3. Yes, we have 1, 2, 3. So this is the histogram plot for the sample distribution, and the key word here is that it only have one sample. Of course, it changes with different sample. Yes, as you can see that earlier, different samples have different combinations of numbers. And lastly, is sampling distribution. And sampling distribution is for instance, we focus on the sample mean. So the sample mean from repeat sampling. For instance, the example we just used was that we have 20 different samples, and we get their means and we plot the distribution. So here we got that's the figure we just showed earlier. Yes, we have 20 means and we plot its distribution. We will see less variation as the sample size increase. So the sample size refers to the size of each sample. So here, the sample size in our example was that the sample size is 10. We have 10 numbers in each sample. So I think that's it. I try my best to explain the central limit theorem, and you find that my explanation is clear enough. Please thumbs up, and thank you for watching. If you have any questions, feel free to comment down below. Okay, I think that's it. Thank you for watching.